Welcome, Earth Science students. This is going to be our teaching point for tonight to determine the epicenter of an earthquake using time difference. During the course of this video, make sure you have your notebook open. We have the teaching point down, and we're copying down our notes, which are in yellow. I'm not going to be reading through every single note. I'm expecting you to pause the video and do that on your own time. Okay. Reading seismograms. So every seismogram will show the hours, the minutes, and the seconds. And we use that data to reveal information about the time difference. So we want to begin by figuring out what each line is going to be worth along that timeline. I'm going to show you that in a second. Then you can calculate the time difference by subtracting the highest value, the S wave, minus the lowest value, our P wave. Let's check that out. Here it is. Our timeline along the bottom, we have to first figure out what each of these lines is worth. I'm hoping that all of us are realizing it's 1 minute. So we're over here at 8 hours 15 minutes. This will be 8 hours 16, 8 hours 17 minutes, right? 18, 19, 20. You can see here also that the P wave and the S wave are marked off. So again, we use that information to give us the time difference. So let's move on here. We have the S wave. We just bring it down, arrived at 8 hours 30 minutes, and the P wave arrived at 8 hours 21. That's going to be a difference of 9. Yes, time difference, we're subtracting. Our difference is 9 minutes. For seismogram B, I'm just going to go through all these just so we're very, very clear. The S wave arrived at 8 hours 26, right? Here's 25, 26. And we subtract that from the P wave, which is going to be 8 hours and 19. Here's 8 hours 15 minutes, 16, 17, 18, 19 minutes. All right, and we get 7 minutes. For the final one, S wave arrived at 8 hours 21 minutes. And the P wave arrived at 8 hours 16 minutes. We subtract those two and we get a difference of 5 minutes. So when we're given our seismogram or we're given it in a word problem, the first thing we're going to do is take down the time difference between the P and the S waves. We then take that data and we bring it over to page 11. We're going to place our blank piece of scrap paper along the y-axis to make sure that we're marking off the zero line as well as whatever we calculated in step 1. Make sure we're keeping the scrap paper vertical, and we move it up through the P and the S wave lines until they match up. I'm going to show you what all this looks like. It's just a bunch of words right now. The 0 minute mark must touch the P wave line, and the time difference we calculated in step 1 must touch the S wave line. Here's a Regents question. When did the first P wave arrive at this seismic station? All right. Well, if we go back to our steps, the first step is to calculate the time difference. So I'm looking over here. I'm looking at my seismogram, and the time difference is going to be 11:05 a.m. subtracted from the P wave arrival time, which is 11:01. So right off the bat, here's our S wave minus our P wave, and it's 4 minutes. So let's go to page 11. We go to page 11, and we're going to take our scrap paper, and we're going to mark off the 0, and we're going to mark off the 4 minutes. We're going to take our scrap paper, we're going to slide it up until they meet the S and the P wave line. We're then going to slide down, making a line, slide it down to the x-axis, and that value is going to be our epicenter distance for this particular time difference. So a 4-minute time difference equates to a 2,600 kilometer epicenter distance. Now in the problem, it specifically said the P wave travel time. We wanted to know what the P wave travel time was. And the seismogram, I'm just going to fly back here. See, the seismogram that we were given just gave us the arrival time. But we're looking for the travel time. We're looking for how long was the P wave traveling for before it arrived at 1101. So somewhere back here, the earthquake actually happened, and then at 1101, at this location, the P wave was first felt, and then 4 minutes later, the S wave was felt. So we want to know, how long was the P wave traveling for? Well, we know it's going to be one of these, yes, because we calculated 2,600 kilometers. So 3 and 4 are out. So either 3 minutes or 5 minutes. Well, let's see how we're going to do that. Well, so we calculated all this. Now, here it is. So 2,600. All we have to do is take where we were along the 2,600 kilometer line, and at the P wave line, just go to the left. And it's 5 minutes. And that's it, 5 minutes. 2,600 kilometers. If we go back to the question, that's going to be answer 2. All right. And again, how did I know that? I knew that because it said, when did the first P wave arrive at the seismic station? Well, 5 minutes after the earthquake actually occurred. I knew it was 5 minutes because I just went to the left here. And that's it. Next problem. Now, this one's on your own. Stop the video right now. I'm going to continue, but make sure we can do this on our own. On the regions, I will not be there to help you. An earthquake's P wave arrives at a seismic station at 2 hours, 40 minutes, and 0 seconds. The earthquake's S wave arrives 2 minutes later. What is going to be our epicenter distance? Okay, just like before, we're given when the S wave arrives, which is 2 minutes after this, and then we're given our P wave. So we got to subtract the two. 2 hours, 42 minutes subtracted from 2 hours, 40 minutes is going to be 2 minutes. We then are going to go to page 11 and use our scrap paper. So we're going to use this number right here, the 2 minute calculation. We line up our scrap paper at the 0 and the 2 minute line. We then take that and bring it up to where it meets the 2 lines, and we bring it down. We're going to bring down that to where it meets the x-axis at 1,100 kilometers. And that's the answer. That's it. That's the answer for that one. Again, stop the video. Make sure we can do this on our own. I will continue. The seismogram below shows P wave and S wave arrival times at a seismic station following an earthquake. This one's great because you don't even have to calculate or figure out what the different intervals are on the x-axis. It just gives it to you. So the S wave arrived at 6 minutes and the P wave arrived at 0 minutes. That's a very easy calculation. It's just going to be 6 minutes minus 0 minutes. So the time difference is 6 minutes. Let's go to page 11. We go to page 11, get our scrap paper out. We mark off the 6 minute and the 0 minute. We then move that up, and we're going to bring down a line at 4,400 kilometers. kilometers. And that's the answer. All right, that concludes our flip lesson for today. Make sure you have your notes in for tomorrow. We will be beginning a 25-minute activity on all the different things we learned today. And that will be it. Everyone have a great night.